Good day. I'm Dr. P.K.S. Nain from Department of Mechanical Engineering at Galgodia University. Today, I'm going to teach you the Introduction to Engineering Mechanics for third semester BTech Mechanical Engineering students. So, the objectives of today's lectures are to identify the difference between various branches of mechanics. Then we will try to differentiate between vector and scalar quantities, and then we will try to understand some basic laws of the mechanics. So the first thing, what is engineering mechanics? So engineering mechanics is the branch of science which deals with the behavior of body when the body is at the rest or in the motion. So basically we are talking of a body which is at the rest or in the motion. The engineering mechanics is further divided into two parts, namely statics and dynamics. The difference between these two sub branches of engineering mechanics are that in statics the body is in the rest, and while in the dynamics the body is in the motion. So the branch of science which deals with the study of a body when the body is at the rest is known as statics, while on the other hand the branch of science which deals with study of body when the body is in motion is known as dynamics. So basically we are talking about engineering mechanics and its two divisions. One is statics and dynamics. So if we want to have a clear graphic picture of this, so we will have to visit the next slide where you see the first one is the engineering mechanics, and then it is divided into parts. One is statics, in which the body is at the rest, and number two is dynamics, where the body is in the motion. So the classification of engineering mechanics which we will be dealing in this course is shown below. So the engineering mechanics, basically we have statics, we can divide it in the statics and dynamics. What was engineering mechanics? It was a study of the body either at the rest, behavior of the body either at the rest or in the motion. So if we are studying the behavior of a body while it is in the rest, so we will call it this such type of study as statics. While on the other hand, if we study the behavior of a body which is in motion, then it will be known as dynamics. Now look at the figure again. The dynamics is further divided into two parts, kinematics and kinetics. What is the difference between these two? We will understand in the next slide. So we can say here the dynamics is further divided into kinematics and kinetics. The study of body in motion when the force which causes the motion is not considered is known as kinematics. So that is the first part. In the first part, when the body is in the motion, there are two factors to be considered. The first factor is the geometrical part of the motion, that is whether it is translating, how much it is translating in the x direction, how much it is translating in the y direction, how much it is translating in the z direction, because a body can be in three-dimensional motion. So if you are looking at the geometrics of the motion, That is, if you are looking at the motion of a body with respect to a Cartesian coordinate system, it is called, or the polar coordinate system, it is known as kinematics. While if in addition to the geometric part of the motion, we also consider the force which causes that motion. So then the comprehensive study, which considers both the geometric part as well as the reason or the cause of that motion, that is, which is force, that is branch of sciences known as kinetics. So dynamics can be divided into two parts: kinematics, that is the geometry part, and the kinetics, which considers geometry plus the force part. If you remember Newton's law, what is a force? Force is an external agency which tries to change the state of a body which is at the rest or in the motion. So it is the external agency. So which is the cause of the motion, which tries to move the body either from the rest or in the motion. So I hope this is clear. To summarize up to this part, we have talked of the engineering mechanics, which is the study of the behavior of body either at rest or at the motion. If we are studying the behavior of body at rest, it is known as statics. If we are studying the behavior of body in motion, it is known as dynamics. The dynamics can be further classified into two parts. One is kinematics, which refers to the geometric part of the motion, and the kinetics, which considers the geometric as well as the force which is causing the motion into its study. Now, let us try to revisit a basic concept which we have all studied in our 10+2. What is a vector quantity and what is a scalar quantity? So the answer is very simple. A vector quantity is a quantity which is specified by magnitude and direction, while a scalar quantity is a quantity which is having just magnitude but it is not having any direction. But there is something more beyond than this definition. What we generally omit while stating this definition, the vector quantity is a quantity which needs to be specified with magnitude and direction both needs to be specified. We don't mention something hidden, and that hidden part is very important for us. That is, the law of vector addition should be followed. If the law of vector addition is followed, then it is perfectly a vector quantity. So vector quantity need to follow two things. One is, it has to be, the first condition is it has to be specified by magnitude and direction, and second condition is the law of vector addition should be followed. Now this definition can be clarified with the help of some examples which I've given at the bottom of this. As I said here, scalar quantity is specified magnitude alone. Now let us look at the electrical current. Okay, electrical current has a direction of flow. It flows from higher potential to the lower potential. So can we say the electric current is a vector quantity? The answer is no. Though it has a direction that it always flows from higher potential to lower potential, the point is that the addition of electric currents is not following law of vector addition. Okay, what is the law of vector addition? This is law of parallelogram or law of polygons or law of triangular addition of vector quantities. So, though electric current has a magnitude say 10 ampere and it has a direction also that it moves from point A to point B, if the point A is at higher potential and point B is at the lower potential, we can definitely say that its direction is from A to B. But if I try to add the two current streams together, they will not follow the law of vector addition. Now, second example, we always thought that area is a scalar quantity, but in engineering analysis, it is not so. We always say area is 10 meter square. Say for a rectangle, we say the area is say 10 meter square or 10 centimeter square, something like that. We never say what is this direction. So, is the area a scalar quantity? The answer is no, because area is also having a direction which we are not mentioning in our journal discussion. Area has a direction, and that direction is basically the direction of outward normal of the area is considered as the direction of area. Hence, the area is not a scalar quantity, is a vector quantity. It has a magnitude and it has a direction which is denoted by outward normal direction of the area. So, I hope so far I have clarified two major issues, that up to 12th class we were generally referring area as a scalar quantity, but it is in engineering analysis you will find area is actually a vector quantity, and electrical current is not a vector quantity, it is a scalar quantity because it has not fulfilled the second condition, which is primary condition to be a vector, that the law of vector addition is not followed by current streams. So, I hope it clarifies the issue very well. Now we come to the basics which we studied earlier. What were the basics? The mass, time, length, the dimensions, MLT. So basically the units are requiring some standards to be maintained. So the mass is measured in generally in units in kilogram in SI systems of units. And what is mass? It is the quantity of matter which is possessed by a body is called mass, and its units are kilograms. Second is the time. It is the measure of succession of events. Say, in the succession of event, the duration is basically measured in terms of time. So, in order to define a standard 1 second, the duration of 9192631770 period of radiation of cesium 133 atom, that duration is considered as 1 second. So, this is a standard definition, so that that it is a reproducible thing which can be even reproduced even if it is destroyed. The standards are destroyed, but the matter is not going to act. So, whenever we consider the period of cesium 133 atom, we can always rework the definition of 1 second. Similarly, the length. Length is measured in terms of meters, and it is considered as 1690763.73 wavelengths of krypton 86 atoms. So, it is basically defined as in terms of the wavelengths of krypton 86 atoms. So, it is a reproducible standard unit. So, this is the basic definition. I hope you remember these definition from your 12th standard. Then is the next basic thing which we will be talking here will be the distance and displacement. Now, if you see at my pointer, the blue vector is showing the blue direction has a tail and then it is having a head. So, if a person or if a body is moving along a blue line, as I am showing by this, the total distance, the scalar distance which is covered uh, is the length of this blue path will be considered as the distance traveled by the body. So, a distance is the distance moved by a body or particle. It is a scalar quantity. We are changing direction in between the motion, but we are not considering that direction change. We are only considering the length of path which the red laser pointer is traveling on this. But if you consider the displacement x is defined as the final position minus initial position. So, if you see, this is the final position and this is the initial position. So, if I subtract these, I get a yellow line which is a shortest distance between the initial position and the final position, and this is known as displacement. So, you see, displacement is shorter than the distance. Displacement is a vector quantity while distance is a scalar quantity. Now, if the displacement is denoted by x, in mathematically the velocity is nothing but the first differential of this displacement x with respect to time, that is dx by dt, and it is measured in terms of meters per second. If we differentiate the velocity again, then we get the acceleration of body A, which is nothing but first differential of velocity dv by dt, or the second differential of the displacement with respect to time. So, that is the acceleration, and the unit of acceleration will be meter per second square. The momentum we will be also considering in the engineering mechanics, and that is basically the product of mass into velocity, and the I am sure you might have studied the principle of conservation of linear and angular momentums in your physics classes in 12th standard. So, just to revise that, this is the definition of the momentum. The most important concept which we will be using in this course is the definition of rigid body. The rigid body is a body which does not deform due to action of the force. So, the body which does not deform, or the body in which deformation can be neglected in analysis, is called the rigid body. And a body is said to be rigid if the relative position of any two particles don't change under the action of force. Like we have oval shape rigid body. I have marked 2 point A and B. This body travels along the black path which I am following like this. It started like this and moved like this and moving like this. So, this orientation is changing along the path, but the relative position, the point A has moved to point A dash, the point B has moved to point B dash, but the distance between AB is equal to distance between A dash B dash. So, a body is said to be rigid if the relative position of 2 points that I have shown here as A and B does not change under the action of force. So, this is the definition of rigid body. Last concept is the concept of continuum, which is very important in analysis. This is the basic assumption required in the analysis in engineering. If you are considering the macro level part, it is not possible to solve any engineering problem by treating a body as a collection of discrete particles such as atoms and molecules. We studied in physics that the matter is made of atoms and the molecules, but if you consider that in this, in engineering, then the problem is that the properties cannot be defined as the continuous function of space. So, in order to overcome this constraint, a body is assumed to consist a continuous distribution of matter. We don't say that within an atom, between a neutron and proton and electrons, there is certain space available, and there are gaps where you will not find particles. But practically what it is, if we are talking of a 1 meter distance or 1 centimeter of a matter, it has millions of atoms in it, and hence practically we can consider that it is just a body is consisting continuous distribution of matter. There is no space in between, and hence this continuity of matter is referred as continuum, and this is treated as continuum, which refers to continuous distribution of matter. Once the distribution of matter is continuous, any mathematical property like pressure, temperature, or any other Young's modulus can be considered as the continuous function mathematically of the space. When a function is continuous, only then it is differentiable or integrable. That is the basic requirement, and we will be using the differentiation and integration in this case in engineering mechanics lot many times. Hence, it is important for us to consider body as a continuum. The last concept is the concept of particle. So particle is an object which has only mass and no size. Is that possible? That means it has only mass and no size, means the density, which is known as ratio of mass divided by volume, will become infinite. But for mathematics it is possible. I will show how. For the time being, consider particle is an object which has only mass and no size, and a particle is a rigid body. Such body, of course, cannot exist theoretically. As I just said, the density of such a material will become infinite. However, for the problems involving distance considerably larger compared to the size of body, it can be considered as particle without sacrificing accuracy. I will give one example for that. A plane, a bomber plane, if you look at the earth and from close distance, you will find it is say 70 meters or some 30 meter, 40 meter long plane. Okay, so it is big enough for us to see when we stand next to it on the ground. But when the same bomber plane is flying in the air and a gunner, anti-aircraft gunner, tries to shoot that plane, how big he finds the plane? It looks like a particle only to him, because the distance between the gunner and the bomber plane is in kilometers or in thousands of meters, while the dimensions of the bomber plane was only 50-meter length. So to him it appears as a particle. So consider, whenever the distances involved in the problem are very large as compared to actual size of the body, we can consider that body as a particle, and that is the basic assumption to be understood. So how much is the distance between bomber plane and the gunner at the earth surface? It is in thousands of meters. Okay, and how much is the size of a bomber plane? It is about 50-60 meters. So 50-60 meter compared to 1000 meters is very small quantity. a very small magnitude, and hence it can be considered as a particle. So that is the importance of a particle. Don't consider that particle is can be of 1 centimeter and 2 centimeter. It depends upon the distances involved in the analysis. So the summary is that that engineering pen problems can be solved if you treat matter as a continuum, and a rigid body can be considered as a particle without sacrificing accuracy, provided that the distance involved are much larger than size of the body. These are two are major takeaway of today's lecture. Now, I will give you a question to think and try to list the 5 practical examples in which you can say that a rigid body can be assumed to be a particle. Try to list that from your memory, from your experience so far in your life. So this is a carry home problem. And now in the last, what are the textbook which we are recommended for the course? The textbook we are recommending are Engineering Mechanics and by Bhavi Katti in a multicolor edition, and Engineering Mechanics by Dr. R.K. Bansal. The reference books are Rao and Young, Timoshenko and Sukumar Patti from Tata McGraw-Hill and Beer and Johnson, Russell, Vector Mechanics for Engineers, and Shames Engineering Mechanics, Statics and Dynamics, published by Prentice Hall of India. So that's all for today's lecture. Thanks a lot for patient hearing and happy learning to you. Thank you very much.